This watch movement was designed by an AI and it caught and fixed its own mistakes along the way. Any LLM can push geometry around in CAD. That doesn't mean the design is right. So you describe a machine in plain English and it builds the real thing and checking its own work along the way. One prompt, a complete mechanical watch movement, one of the hardest things to get right. It builds every part live in FreeCAD, verifying after each one. Then, in one unattended pass, it catches a problem of its own making. Two wheels in the train don't quite mesh, off by 3/4 of a millimeter. It measures the error itself, computes the correct position, moves the wheel, and propagates the fix to the rest of the train. The train closes, the movement runs. A watch is just geometry. The harder question is physics. Does it survive contact, gravity, and load? A quadcopter flown in PX4 flight simulation. It tracks the mission. A hexapod the model designed dropped into Isaac Sims' GPU physics. It walks, all 18 joints, real rigid body physics, not an animation. Same loop, a different physics engine for each machine, and the layer is open. As simulation gets better, so does everything it builds. AI mastered the digital world by iterating in it. Simulation lets it iterate in the physical world too. Atoms finally moving at the speed of software.